Now I want to talk about linear time invariant equation. This sounds a little difficult, but actually it's very simple. Let me write down the protein degradation difference equation. So y of y is equal to p sub y times y I minus 1. And p sub y is greater than or equal to 0 and less than 1. Basically, this equation is saying the current value of Y protein depends on previous value of Y protein, right? And we may call this Y of I minus 1 input and Y of I output. So we can have this relationship. Let's say our P sub Y value is 2. So Y of I is 2 times Y of I minus 1. And let's say if this value is 1, okay? And what is this value? The output is 2. How about if you increase this input by 2? Then we get this value 2. And here we have 4, which is also 2 times larger than this output. If you increase your input 4 times, so from 1 to 4, what do we get? We get actually 8 here. And also we see that this is increased 4 times. So this is linear relationship. The output and input has linear relationship. So let me draw a plot to show the relationship between input and output. So we have y I minus 1, which is input, and we have y of I, which is output. And if you draw the relationship, we have something like this. And the slope in this case is p sub y, which is 2. So you pick any point and you see that we have 1 here, then you have 2. If you have 2, you have 4, something like that. Note that the protein degradation dynamics plot we saw before was something like this. So we have y of I, and we had I here, which is discrete time index that represents time, right? And we saw something like this, exponential decrease. The thing that I want to stress is that even though we have this linear equation, the dynamics can be nonlinear. Now I want to talk about time invariancy. If this parameter p sub y is constant or time invariant, then our equation is time invariant. That means the relationship between y of I and y of I minus 1 is not changing. It is constant. That's what we mean by this time invariant equation. Can this parameter p sub y change? Yes. So we can have equations something like this. Y of I is p sub y of I times y of I minus 1. So in this case, this parameter p sub y depends on time. So not only y values change over time, but also this parameter value py changes over time. And this is called time varying equation. Since this is a linear equation, we can say it's a linear time varying equation. In my course, we will look into this time varying equation when we study adaptation. We will see that basically this parameter value can adapt for better estimation. We can also have equation which is nonlinear time invariant. Y of I is equal to py times y I minus 1 squared, for example. Now, we have this p sub y, which is constant, meaning that our equation is time invariant. But the relationship between y of I and y of I minus 1 is not linear anymore. Now we have y I minus 1 on the horizontal axis, and you have y of I on the vertical axis, and you will see something like this. You will see basically a parabola. We will see nonlinear time invariant examples in my course.